intercept form of a quadratic equation. It reads f of x equals a times x minus h times x minus k. Just think of this equation as the skeleton of our function. The letters h and k represent the exact spots where our graph crosses the horizontal x-axis. And that letter a, that's our scaling factor. It tells us whether our curve opens upwards or downwards, and just how wide or narrow it is. So all we have to do is find the numerical values for h, k, and a from the graph to totally crack the case.
Which brings us to part 3. Clue 1. Finding intercepts.
Let's dive right into a real case file from example 3 to gather our first set of clues. Look closely at exactly where this blue, upside-down curve actually crosses the horizontal line, the x-axis. You can clearly see it hits at two distinct locations, at -1 and at +1. Now, these aren't just random dots. They are our h and k values literally hiding in plain sight.
As the textbook solution outlines for example 3, these visual intersection points hand us our first really solid mathematical clues. We can extract that h equals -1 and k equals +1. Boom, we already have two of our three missing pieces. By plugging these h and k values into our intercept formula skeleton, we successfully build the foundation of our equation. Notice the algebra here though. Because our formula is x minus h, subtracting a -1 actually becomes x plus 1. It's a great example of how visual coordinates translate perfectly into algebra. We now have y equals a times x plus 1 times x minus 1.
But hey, every good mystery has a twist, right? Here it is. Just knowing where the graph crosses the axes is not enough to identify it completely. Think about it. There are infinitely many curves that could pass through those two exact intercepts. Some could be super tall and skinny, others really short and wide. To lock down the exact identity of this specific curve, we absolutely have to find that missing a value.
So let's find it in part 4, clue 2, the specific point. To find that missing a, we need to go back to the scene of the crime, our graph, and find one more crucial piece of evidence. If you examine the graph again, you'll see we aren't just given the intercepts. There's another perfectly clear, explicit point labeled right at the very peak, or the vertex of the curve. It is the coordinate 0, 4. This means when the x value is 0, the y value is exactly 4. And this single coordinate, it's the key to unlocking our mystery.
On to part 5, solving the equation.
Now we take all the clues we've gathered, our skeletal equation and our specific point, and put them together in the interrogation room to force out the final answer. The way the textbook handles this is honestly a thing of beauty. We take our specific points x and y values, 0 and 4, and we just substitute them straight into the equation we built earlier. Where there was a y, we write 4. Where there was an x, we write 0.
Look at what happens to our equation when we do this.